Today was a show all about climate change and science. We have a distinguished guest today with a varied background he's an author, he's worked in the computer science industry, and he's also the CEO of Worldfree, a digital currency software firm and editor of the Client Science Journal, which seeks to restore higher standards of integrity and scientific openness to the debate. He also has degrees in mechanical and aerospace engineering, as well as graduate work at LSE in philosophy. He's also the author of a book called Aspirations, the Rational Foundations of Achievement, and he's also worked in the computer industry since 1974. So this is a difficult subject for many that are basically following the mainstream agenda on climate change. I'm still a little bit on the fence myself, but I wanted to have somebody on the show who was contrarian to this whole flow of information. But I needed to have somebody on the show that had spoke from a lot of experience and is familiar with the science. So this show really kind of blew me away. Lots of curiosity was accomplished for myself, and I just hope you like it. So here we go with the show. Let's go. So welcome to the Nico Show. Today in the show we have Kevin Kirchman, and he is an entrepreneur with a very wide experience. And he's calling in today from Orlando, Florida. How are you doing today, sir?
Great, Nikos. Thank you very much. Yeah,
So I'm quite interested in your experience regarding climate change. You've already wrote quite a few articles on the topic and some scientific papers. So I was just wondering what made you interested in that topic and what you've kind of recently discovered.
Okay. Yeah, I had a renewable energy firm where we were developing a vertical axis wind turbine that captured CO2 from the air and then cracked water into hydrogen and oxygen, and then used the hydrogen with the CO2 in a reaction called the Sabatier reaction to create synthetic natural gas or synthetic methane. And so the idea is, of course, to store the energy in the form of this synthetic natural gas and then use it when the wind wasn't blowing as hard. So I developed this technology, understood for the last more than 20 years that CO2 was an issue. And as an entrepreneur, you basically feed on problems. You like problems because that's the opportunities in life. And so when the world said CO2 is a bad thing, I said, oh, well, let's use CO2 for a good thing. So therefore, we can solve that problem. But in the field, developed these prototypes, and it was exciting. And we actually had a venture commitment from an EU venture fund, an official venture fund from the EU. And then I think Cameron was elected, and they changed the standards for wind turbine subsidies, and we had built our financials on those. We didn't need them, but nonetheless, it interrupted that flow. But while I was working on it, I started finding some conflicts in the story about CO2, and so this was back in probably. I really started getting serious about this, the legitimacy of the CO2 problem back in 2010 or so. And I wrote people in the field, scientists in the field, and then started doing a background study in the subject. So I have a degree in mechanical and aerospace engineering, and really had a focus and specialty in heat transfer, which I really liked. And so I went to Cornell, and then so I basically had all the tools and the foundation for a commitment to understand the field. So I've spent pretty much nearly or more than 10 years dissecting the arguments and studying the physics, learning about the history of the greenhouse gas or the greenhouse theory with CO2 and methane and water vapor and the other greenhouse gases. So that was sort of the background, but I felt that it wasn't legitimate, and so I needed to get to the bottom of it. And does that answer your question?
Yeah. So just going to ask a few curious questions. So basically, when you said vertical axis wind turbines, what does that mean?
Well, you know how you've probably seen the helical type vertical turbine. Ours was special because it was a variable radius vertical wind axis turbine, which has a lot of value. But it basically, you know, the horizontal axis wind turbines are the normal ones you see, and where they spin on an axis that's horizontal to the ground, whereas the vertical axis wind turbines, they spin on an axis vertical to the ground. So that's the basic difference. And there's some advantages of the vertical axis wind turbine, and we were capitalizing on those. So it's a great project, and it's still a real value for remote locations. I think that's a great opportunity of renewables.
So are these quite small compared to the vertical ones? Sorry, the horizontal ones?
Yeah, well, the big challenge, of course, the horizontal axis wind turbines have gone through an evolution so that they're really big now. Okay, so you with everything, you got to build a prototype first, then you build the first model, which is one size. Then as the industry matures, they get larger and larger and more efficient from economies of scale. And so vertical axis wind turbines haven't really gone through that development cycle because of the commitment to the horizontals. And a lot of the commitment is just because that's what investors are used to, because investors really drive a lot of the decisions in the development world. If they just understand horizontals and have experience with horizontals, and that's, you know, and they make money with horizontals and they stick with horizontals, and they, you know, why would you don't switch if it works, basically. And so, yeah.
Do you think the horizontals are more popular because they're at a higher altitude than the vertical ones?
That's possible. Again, you could kind of, yeah, I guess the verticals will, it depends. I mean, it depends on the geometry. You can make them taller just by building a taller tower, you know?
Yeah, I guess so.
Yeah, it's not too much. It's really a geometric job, you know. It's to develop a turbine is all about geometries, and what you're trying to do is maximize the area, because that's the basis of your power production. So that's what that's about. But to understand it and then turn around and then challenge the paradigm and to be involved, because we still have technologies, and I still like what we're doing, and so one day I'll return to it. But like I say, no longer am I driven by the need to reduce CO2 in the air. I think CO2 is an opportunity to create hydrocarbon fuel for renewable energy. But I don't think basically I don't think it's an enemy of our society. In fact, it's a chemical at the basis of life on Earth. And as I discussed in one of my papers, my real opinion is that CO2, because of photosynthesis, it's an endothermic reaction, photosynthesis, of turning sunlight into carbon in the trees and the plants on Earth, and then basically releasing oxygen, O2. And this photosynthetic reaction, being endothermic, means it takes the sunlight and converts it into carbon, which means it has a net cooling effect on the planet, is my opinion. So when you add up all the implications, and I have, then you'll find that CO2 is actually a cooling effect on the planet. I mean, a desert is without plants and needs the water to grow too, but is a hotter place than a tropical rainforest. And that's because of partly water vapor, but also because the sunlight is being converted into carbon. And so it stores the thermal energy rather than absorbing it. And absorbing thermal energy in mass heats the surrounding area. So I'm going against the grain here on the topic of carbon dioxide, but now I've really dug into the physics of the matter, and so I now understand. We have some. You know, I'm going to digress for just a second. There's something called the Standard Model of Physics has been developed over the last 50 years or so, and it's the sort of the latest knowledge about the nature of the world and the universe. And so that standard model says that photons are absorbed by electrons and neutrons in atoms, in all atoms. Okay, so that's the standard model of physics. The greenhouse gas theory comes from is about more than 100 years old, from the latter part of the 19th century and early 20th century. Arrhenius and Fourier from the early mid 19th century really are responsible for the greenhouse gas theory. But that basically says that the molecules like N2 and O2, they only have two atoms, nitrogen and oxygen. And these two atoms are limited in their capacity to absorb thermal energy, because it is presumed that basically, and I don't want to get too technical, but it's presumed that they're limited in their degrees of freedom. And so that this limitation causes them to be less able to absorb infrared radiation.
Right.
And infrared radiation is the real discussion here, because that's the ingoing and outgoing energy. So the idea is
just to jump in there, the absorption, basically what happens is the radiation is light energy or electromagnetic energy, and the molecules will absorb it by basically the light wave will cause electrons to jump up to a higher energy state and absorb the energy of the
That's correct. That's the idea. And the energy state could be one of the many, again, a lot of this is technical, so I don't want to get too focused on the technical, but there's these degrees of freedom, whether they're rotational or vibrational. But it's the translational degrees of freedom. Okay, rotational degrees of freedom means that the atoms, like in vibration modes, is the energy excitation that you just mentioned, is where we're in a CO2 atom, you have two oxygen atoms and one carbon atom, and they're shaking or vibrating with respect to one another, and they can stretch in this axis or that axis, or rotate or whatever. And those modes are where the molecule stores the thermal energy. Okay, so that's how
like a Polaroid filter with the light at a different angle, and certain angles will cause it to.
Yeah, that's exactly right. Certain wavelengths of light get absorbed, and other ones just pass. Okay, so that's the paradigm of the greenhouse gas theory. Then the standard model of physics says that all the molecules, because all the atoms, even the individual atoms, will absorb or interact with the photon.
Yeah.
So there's two different things. They're saying contradictory things. The standard model, the latest theory, says that that all these atoms in the molecules all absorb photon energy, and they do so and this is the substance of my major paper on this issue, is that they do so by what's called Rayleigh scattering, which is an old understanding, again, from the latter part of the 19th century. But they do so by increasing the photons increase the velocity of the molecules. So that's the translational degree of freedom. Okay, so what happens is the photons scream through the atmosphere at the speed of light, and there's all these molecules bouncing around already at around the speed of sound. That's about how fast they move about in the atmosphere. But the speed of light is about 900,000 times the speed of sound. Okay, so when a photon screams through the atmosphere and encounters one of these atoms and one of these molecules, it doesn't change its energy level, okay, all the time. Sometimes it does, but what it does is interact with the photon with the electron and the neutron in each of these atoms, and it basically passes momentum. Right. So as we know, photons, they don't have a mass. The photons are the packets of light. Okay, they don't have mass, but they do have momentum.
So basically, the photon will reduce its frequency and energy and pass that on to the molecules.
Yeah, it does.
That's why the light goes red.
Well, that's right. We do know that. If we're going to take energy away from a photon, that means we're going to change its frequency, its color.
Yeah.
Okay, that's basically how it works. So we see that when we see the The best example of of this effect is in a sunset or a sunrise.
Sure.
And you now, they're granted, there's some particles in the air like dirt and such, and dust, but those are water vapor. But substantially, the colors of the sky are affected by Rayleigh scattering, which is the photons pushing along the molecules and atoms at a higher speed, and that is changing the color of the photons, and that's what gives the sky its hues.
The amazing things with these things, like, scattering and energy absorption, these are effects that we can see and measure, but actually to imagine what is actually going on, people don't even know what magnetism or electric fields actually are, and how what happens at like the subatomic level, but we just seem to measure these things. And
exactly, yeah, I think you're right. We've lost connection. We can see the trees, but people have lost the capacity to see the forests, and we can't, and we're not, because of the massive increase in technical and scientific understanding. We can't. First of all, people have a difficult time comparing the different theories and assessing which are valid and which are not, because science has to rise. It's not supposed to be stagnant with the masses of contradictory knowledge. It's supposed to, we're supposed to have to reevaluate our perspectives on knowledge and prove it from contradictions. That's our opportunity. Again, like an entrepreneur, the opportunity of science is to find contradictions in theories. If you can find a contradiction in a theory, that's generally with respect to the world, then you know that somehow this theory is not correct. And that's what I saw with the greenhouse gas theory. I said, wait a minute. There's too many things. Okay, and another one. There's an example of this. So when anybody listening, they go out at the end of the day, if they have a relatively clear sky, you look at the horizon, and it's red to orange, and then to green and yellow and blue, and darker blue, and all those colors are created by the increasing absorption. Closer you are to the horizon, the more energy has been absorbed, and therefore the more red it looks. And because the red is is a longer wavelength, and when you absorb energy from a photon, you're basically taking it from a shorter wavelength to a longer one. And so that's one example of where a physical world, you should be connecting it to the theory. Okay, so another way you can connect the physical world to the theories is by observing unique events. And for this example, an eclipse of the sun. Right, so you got the moon moving in front of the sun. Okay, so we look at, if you have ever been in a total eclipse. It gets really cool fast. And this is one thing that I recognized. I was in Georgia at the time, and it just amazed me how quickly the air got cool, or about 10 degrees or more. And so that means that as soon as and this is really important, as soon as the sun light was blocked, it got cool. So the question is, where's the greenhouse? If as soon as you shade the sun, even with a cloud, you don't even need an eclipse. As soon as a cloud comes overhead, it gets cooler. So where's the greenhouse? It gets cooler with it. And for an eclipse, we can time it because we know exactly when the eclipse is going to happen, basically astronomically. And so we can be ready with a timer. We can time when the sun is shaded and in complete shaded at various phases or whatever, and what is the temperature, so we can have immediately recognize it. Practically, we can do it without a thermometer because we can sense the temperature difference. So where's the greenhouse?
Well, I think that for me, I think that the temperature difference you feel is not really the air temperature. It's more rather the effect of the sun's rays on the skin, which make you feel warm or cold.
Yeah, I would definitely say that's true, but I would also say that the temperature drops too, and it does drop from anywhere from 5 to 25, 30 degrees Celsius. And so that's, I mean, all over the world. You can Google it. Nowadays, it's we were talking earlier about the lack of people's willingness to rise to the occasion to challenge scientific knowledge. My goodness, we as individuals have at our immediate, we're able to access immediately the whole of human knowledge. We've got no excuses.
I think it's basically the ordinary person doesn't have the confidence to challenge this stuff, because you're immediately presented by scientific papers that you need to have, professional training to try and to understand. Just start reading equations and
to be honest, once you acquire competency in a technical field, and you get into it and you start reading some of the papers, one of the first things I started asking myself, are you guys making it more complicated than it should be? And then you realize, well, they're trying to defend their jargon. Their jargon helps them defend their professional stature and maybe their income and their ability to generate income. The more complicated they make the field, the less accessible it is to the general society.
Yeah.
So they have a mischievous or devious motive there to make things more complicated than they need to be, and that's not good. So people do, as you said, they if they don't have a technical competency, then they do lack self-esteem, intellectual self-esteem. Yeah. And I've had conversations with really well-meaning and honest people who really wanted to understand things. And when I started talking about nuclear physics, I said, hey, just spend a little time, it takes 6 months of your lives or your life and learn nuclear physics, and because it's really cool, and you've got all that stuff right there. And the responses I get are like, I just don't think I have the confidence to do that. And so I think we've got an unstable internet connection.
For about 10 seconds there it was.
Okay. Yeah. So basically the idea that we are our education is not fulfilling that promise any longer. We should all walk out of our early education even with a grasp of general physics, with intellectual confidence and the capacity to assess the validity of ideas and to reason from them capably, and know that and be able to be comfortable with nuances of understanding. And I just don't think people are. So in spite of our incredible opportunity to have all this knowledge available to us to challenge any idea that is put forward, we just don't, as societies, we don't have the confidence in the general case. And that's a bad thing.
And look at all these vaccines, right? Because I think the vaccines are more complicated. The biology is more complicated to me than just the interactions of photons with molecules in the atmosphere. So I think it's going to be, the general public are going to be even less informed on that topic.
Could be. Now I'll digress there for a second too. I mentioned in one of my books, I said, hey, it's the the hydroxychloroquine issue, HCQ, and they with zinc. Okay, so I asked myself, okay, so what's the deal with this? And basically, the HCQ makes it possible to raise the pH inside a cytoplasm, inside a cell. Okay, so for me, I walk in the world of medicine because I have at my command all the knowledge, and being technically competent, I can assess the validity of these ideas. So I walk in there and I say, okay, so we know that a high pH will kill this virus. Okay, so it's generally understood. Okay, so how can we make the virus, or how can we have a higher pH in our cells so we can kill the virus? Because the virus basically gets in each of these cells and it just starts replicating using the RNA mechanism, and it starts replicating, and then it starts spreading, and then it blows the cell up and starts going everywhere else, and that's what happens. But by increasing that's how the quinine works. It basically increases allows the cell inside the cell to increase the pH. And
Yeah.
zinc is an ion that goes in there and does that increasing of pH. So that's how it works. And that more than 1 billion people have taken HCQ, but it has to be used quickly. As soon as you're exhibiting symptoms, it has to be administered, because otherwise your body is just overcome with the virus, and so you miss your opportunity. And so I don't know. Right now we have the virus or the vaccines being pushed to society when they should have pushed HCQ, which already had 1 billion users.
Yeah, this is probably the number one thing that got me skeptical. Like this thing right here, and then doctors being told that they can't use it. I'm like, what the heck's going on here? You know?
Yeah, no, I agree. It was too weird for me, having already gone along with the CO2 idea in the beginning, built a company around it, and developed technology. You know, taking the assumption that CO2 was a bad thing, or as a threat in some degree, and then discovering that these guys are full of it. That this stuff there's nothing wrong with CO2. It actually has a net cooling effect on the planet through photosynthesis, and it's the basis of all the. You gotta realize phytoplankton. My goodness, what zillions of tons of phytoplankton, and all the trees, and all the plants in the world. They're the basis of the animal kingdom, because we all eat ultimately the plants are the basis of the food chain. So here we are saying, and the carbon of the plants comes from the air predominantly. It doesn't come from the ground; it comes from the air. So the CO2 in the air is the basis of all life on Earth. And it's an endothermic reaction in photosynthesis. And so it's taking the heat out of the atmosphere. So CO2 allows the atmosphere to cool by creating plant life. So it's like, whoa, I mean, how are these people going on with this point? It's 0.04% of the atmosphere. Man, we are lucky. We've got that baby, that little tiny amount of CO2 in the atmosphere. My goodness, a lot of scientists are saying, because everybody's challenging the CO2 now, but a lot of scientists are saying that we historically we're at a really low level of CO2. And so this is, but then, like I say, as soon as you discover an consistency in such a glaring inconsistency, then you automatically become skeptical of the next issue, and the one you've hit there, the vaccines, the irrational behavior, the politicized, it's a politicization of the presentation. You can see somebody's gaining somehow from this, because they're not talking sense, and there's other ways to say that, but they're not talking sense. And so what we have then is we have to all, okay, so there's no one is going to tell you what fake news is. Nobody's going to tell you how to assess the validity of ideas. It's something you have to learn yourself. And so all people have to learn to think. Okay, what is that? That's called education. Okay, now, so when we're not capable and confident in our ability to think for ourselves, then we got a problem. And that should not be happening. It should be working the other way. You should be able to get out of high school and be a competent, capable young professional. Okay, before you even enter university, you want to enter university. You want to gain specialized knowledge, and so at that point you should be, capable of making a living at all in the first place, and you should basically be able to augment your living with education. We should have a different kind of world than we have, but we've got what we got. And the most important thing is how can we improve where we stand? And because there's so many of these forces acting that are with questionable motives and peddling misrepresentations of reality, it's not going to be an easy job to improve the human condition. Or I don't like to use that Humean concept, but the state of our world is going to be difficult to change and improve because there's so much disinformation. But anyhow,
Somebody keeps trying to phone me. I keep trying to turn it off in the Mac. So anyway, let's get back to the what you said there about low CO2. So the last podcast with Steve Keeney, he said that CO2 seems to be increasing from around 200 parts per million to 400 parts per million. So
Yes.
one of the difficult things is that it's hard. I've not actually went and did the research myself, but people from, distinguished people from both sides of the camp can say things that conflict. And where do you go to decide what's the actual truth?
Okay, well, I would say I'm not sure about the 200, but we see from the Hawaiian Mauna Loa, whatever it is, there's a data center there that basically has been measuring a very consistent increase in CO2 levels in the atmosphere over the last decades. Okay, so this is I study everything because I like this stuff. I have I don't know. I was a gifted child, and I was admitted to the top 10% of class in Cornell, and I'm high IQ and all that stuff. So the point is, I like digging into this stuff. It's like some people go, I like pool too, but some people will go play a game of pool. I like digging into this stuff, and so it's sort of my thing. Excuse me.
I had a guy on the last episode called Steve Keenan. He's very much on the side of
in terms of the concentration. Yeah. The 400.
He's saying that the concentration is increasing of CO2 right now, but you're saying it's lower. So I'm trying to figure out where do I go to find out the facts.
Right.
I both respect you a lot, both of you, so I can't just say what one of you
is right or wrong. It's a question of scale. If you look over the 1,000 of years scale, it's been increasing, or even on the hundreds of years scale. On the millions of years scale, it's a different issue. We've had above 2,000 parts per million, or we're right now at 400. So it's way below. And I don't want to talk about the different periods of history, but during different eras of Earth's existence, we have had much higher CO2 levels, and remember that plants evolved in these periods a lot. So they came from times when there was much more CO2 in the air, and therefore the CO2 growth rates. I think you'll have to check on this, and anyone could check on it. But greenhouses often augment the CO2 in their inside. And I think they like about 1,000 parts per million. So that's about 2.5 times is their optimum CO2, and it's economic for many of them if they're growing high value crops. So the world the plants, the base of the food chain, want more CO2. But let's going back to that Hawaiian data collection example. So digging into it, what I found is, okay, so we do have an increasing amount of CO2, but on the millions of years scale, it's not very much in Earth's history. But on the local time scale, it is going up. But they put this data collection center in Hawaii, which is surrounded by the Pacific Ocean. Okay, so one of the things we know is that if you raise the temperature of water, CO2 it becomes less soluble. Okay, CO2 is in Coca-Cola, for instance, a bottle of fizzy drink. So if you raise the temperature of the fizzy drink, it will exhaust CO2 because it's no longer, it can't keep it in there anymore. It's not soluble. The solubility changes with temperature. In fact, it's very dependent. So what am I saying here? Okay, when the ocean water warms, it releases CO2 into the air because it can't hold it anymore. In fact, it releases a heck of a lot of CO2 with even a 0.5 degree temperature change.
That's scary.
Yeah, well, it also, remember that 70% of the Earth is covered with the ocean. So when the water warms just a little bit, okay, but we're not going to say how it warms. Let's just say it warms, okay, by just a little bit. Then it's going to exhaust CO2 into the air, and the concentration of the CO2 in the air is going to increase. So and this is going to happen right away. It doesn't take long for, once you've raised the temperature, and so we have there's a correlation between CO2 in the air and the seasons. Okay, so you have to look at all this stuff to validate this knowledge, right? But so if you put your CO2 measuring station in the middle of an ocean, then it's going to, it has a seasonal variation. You can see it on the chart, but it's rising over the last decades. So the question is that because the water is getting warmer, or is it because of the human influence? And unless you're going to have to be pretty, honest with your analysis to be able to decide which one it is. And I say I am sure that industry and people, we exhaust every time we breathe. We exhaust CO2. So the more above us there are just breathing, we're going to be increasing CO2 on Earth. But obviously, when you burn hydrocarbon fuels, they exhaust CO2 as a byproduct. And so that's just the way that works. So we do increase the CO2 in the air, but so too does the warming of the water. Now introduce some other data, which is basically the solar cycles, and you start to see more correlation between the temperature of the Earth and the solar issues. Now I can get into this. Maybe I should just. Is it okay if I just?
Sure. Yeah. This is a hardcore tech podcast sometimes, so no holding back, man.
Okay. Well, we're only learning now about the sun cycles, the solar cycles. We're finding
that.
Yeah, there's Zarkova is a lady. She's actually out of the UK, of Russian origin, I think. But she basically, or maybe it's Ukraine or somewhere over there. But she basically tried to figure out why these 11-year cycles in the sun, or 22-year, however you want to look at it, were occurring. And she discovered that there is a magnetosphere of the sun is causing these things, and she can go into the intricacies. And basically, she said, "Hey, we're getting ready to have a solar minimum." And she said this a few years before it happened. And she said, and she was talking as a YouTube video on her talk in front of a university crowd one day. And she basically said, "Look, you may agree or disagree with me on whether the solar minimum is coming, but why are you? It's going to be here in a few years." And the fact of the matter is, after a few years, it was there, and NASA, everybody agreed, solar minimum. And so now we have. So basically, what is the mechanism by which the solar cycle affects life on Earth? And so some other people have discovered why that is. And I'll explain it. It's really kind of cool for me anyways. Basically, when you have a high solar activity, which is indicated by more sunspots, you have more solar winds impacting the Earth. So that's a correlation. Well, these solar winds blowing over the planets and Earth, they basically are doing us a favor by shielding something else, which is called cosmic rays. Now, cosmic rays are particles that are coming from the rest of the universe, predominantly our galaxy, the Milky Way galaxy. So these things are coming from like solar star explosions and supernovas and all kind of stuff. Okay, and they're
black holes, jets.
Yeah, all kind of radiation is coming from outside our solar system, and this is called cosmic radiation, and it's a bunch of stuff, and it's particles, and these babies are traveling at super speeds, and they can do us damage to our persons biologically, but they also do something else, which is when the cosmic radiation is higher, because we measure this stuff now, then what we find is these cosmic particles are ionizing the molecules in our atmosphere. Ionizing, meaning breaking off electrons and causing them to have a negative charge. And the negative charge, and when this happens in water vapor, in the atmosphere, then the negative charges start to attract the positive ones, and then they start to agglomerate into aerosols, into droplets. So there's a correlation, and it's been demonstrated and worked on. So you got more cosmic radiation causes more aerosols and more cloud cover of the Earth. Okay, so that's the beginning of the chain of reasoning. So the solar flares, the solar winds, they are shielding the Earth from cosmic radiation. So when you get more sunspots, you get more solar winds, you get less cosmic radiation. You get less cloud cover because less ionization of these high altitude molecules. So we get less cloud cover with more solar radiation. So even it's not just the solar not with more solar radiation, but with more solar winds. So it's not just the solar radiation that's the concern, but also the effects of the greater solar activity caused by the magnetosphere of the sun. So this is what's basically affecting. Now, what happens when we have more clouds? Well, more clouds in higher solar activity times, more clouds in lower solar activity times, basically means that more solar energy is reflected from the Earth. Okay, so it's a bit of a convoluted chain of reasoning, but it's all very, very sound fundamentally. So you get more clouds, and more of the sun's energy that is hitting the Earth is getting reflected by the clouds, because cloud reflection, it's called albedo. Basically, so the whiter these clouds are white, so they reflect the sunlight. Okay, so when you got more cloud cover, you have a cooler world. Okay, so that's how it works. So when you have less solar activity, you have a cooler world. So that's the causal argument.
So I would have thought that if it was a higher solar activity, there'd be more evaporation in the water, and there'd be more cloud cover.
The solar activity does not necessarily correlate with solar. That's I try to explain. It doesn't necessarily correlate with solar radiation. Right. So we still get the sun is just still as hot. It's just it's more the solar winds are what the predominant causal influence of the greater solar activity. Okay, the solar winds then are shielding the cosmic radiation, which is the one that's driving cloud formation. Okay, that's now, but on a more weather scale, I started flying gliders when I was 14 years old, and I got my whatever. So I'm a bit of a meteorologist, anyways, and so yeah. So basically. The sun comes up. I mean, here in Orlando is where I learned to fly. But so the sun, as the sun rises in the daytime, it heats the Earth, and the warm Earth rises the air. It picks up the water vapor, and then it condenses and forms clouds. And so the hotter days in the summer here cause more cloud cover in the afternoons, and we get our rains in the evening. Sort of that's the way this Florida works in the summertime. And so basically that you can see the solar radiation doing its job on a seasonal basis to affect local weather patterns, which tend to cool the days as at the ends because of this rain. So it gets kind of cool. And so, I mean, yesterday it was sweater time in the evening because of the big storm that passed. It cooled everything down. But nonetheless, so yes, solar radiation does affect, obviously, the cloud cover. The hotter the sun is, or the more seasonal variations have much more to do with solar radiation levels, and a lot of people have acknowledged this. So the solar radiation is not changing a whole lot, but it's the solar winds that are the issue here, and that's working through the shielding of the cosmic radiations, which is causing the cloud cover. So that's again, look, every idea that I express, you're listening to me, and you're each one can be assessed for its validity. It's my job as a scientist to assess the validity myself and not make any mistakes. So
I just
you
want to say that
can't.
I'm very impressed that you were somebody who had a vested interest in climate change and your companies, the green tech companies, and you've objectively looked at the data and decided that you don't agree with the narrative. So I just want to applaud your bravery for that and potential financial loss for
Yeah, I mean, you could say that I'm, stupid in one sense and smart in another, or something like this.
It's
But
beautiful, mate. It's beautiful to see.
well, to be honest, to be honest, I still like my technology for remote locations. Okay, so I still think it's really cool, and I still think it's a value economically. And right now, the world has gone hog wild over renewables, and it's a bit too much, and it's going to pay if they and right, and the reason, look, you can look at it kind of short term interest versus long term. If we kill fuels, which is what's happening, hydrocarbon fuels, if we kill hydrocarbon fuels, we're going to be in deep trouble. Okay, and that's bad. We really need these things. We are able to have in life nice homes and places and travel and see the world and do all kind of things and have cool lives and be very, very productive because of fuels, because they multiply our ability to work. I mean, as an engineer, as a mechanical engineer, you need this energy gives us great capacity to multiply our efforts. So humanity with 7 billion of us, we need fuel. We take away our fuel and we're screwed. Renewable energy, I really know this stuff. So just so you know, I've had to pitch it to investors for years. So and I understand it. So basically, when you go to an investor, you're basically saying the market value of the renewable energy and what we're going to do. And when you're convinced of the threat of CO2, even if it's not a real threat, you use that as one of your persuading concepts, or but mostly I don't think that I think the threat of the loss of the use of low cost fuels is certainly much greater than the threat of CO2. So to me personally, I don't want to living in a world without low cost fuels is from my interest a greater threat than this silly CO2. I mean, I don't want to call it silly because CO2 is wonderful. It's like, if you had a list of the best chemicals on Earth, CO2, H2O, those are the ones that are on there, right? And we need those babies. And so CO2 is the basis of life, water too, and we need oxygen, obviously. And so these things are great chemicals. CO2, it's so important for life, and we're like there are ants, and ants and termites. These are little tiny animals with little tiny brains the size of a pin, and these things live, and yet we've got these big brains as humans. And we don't want to use them to misrepresent reality, because then we'll be stupider than the ants. And that could be a real bad deal, And I when I see all these, the Hollywood movies pushing the ant world, as a justification for universal tyranny, basically, I say, well, they're making us as stupid as the ants right now.
The Bible, there's a verse in the Bible that says to the lazy person who doesn't want to work, that says, go to the ant, you sluggard, and look how they prepare for their food in the wintertime,
Yeah, well, that's right. And one of the things we can do is, if we I don't think ants probably have enough brain capacity to misrepresent the world. Only, and most animals don't do that either. So you could take a dog. I mean, does a dog misrepresent reality? I mean, we are able to write things down. We can say, look, the sun is a bright purple color. And you go, that isn't right. So I could write that down or say it and write it down. And if a whole society got behind the sun as a bright purple color, then it would be, then that would be one weird society. And but if everybody starts screaming that CO2 is bad, CO2 is bad, when CO2 is one of the chemicals at the basis of life on Earth, then we start looking pretty silly as a species. And
I'd like to talk more about the standard model of physics. I wanted to just comment that this sort of reality upsets. So you got a company like Morgan Stanley right now, which is promoting all this diversity, which is fine, and inclusion. But then they're turning around and saying that if you're not double vaccinated, you can't come into our offices as a client or an employee. So why is there a disconnect there? It's like, this kind of question I have.
Okay, this we can talk about on another day, but I'll definitely address it. We are in a world of political change. Okay, then we're going to have people wanting to get in good with a new regime. To put it one way. Okay, so let's just say your company is XYZ company and you have 20,000 employees, and you sense the winds of political change, and so you've got to connect to Pravda now. You got to sing the Pravda hymn. Otherwise, you've got to suck up to the Vatican if you're Galileo, so to speak. And you don't, and so these are. So when the companies are saying all this stuff, this virtue signaling, why are they doing it? I mean, I don't think they're doing it to sell products. I think they're doing it to gain approval of the political powers. It's like the companies are all lining up to tell the emperor what beautiful clothes they're wearing. That's the world we live in. So all this virtue signaling is really another way to describe it is sucking up. Okay, so that's the world we live in. If I was 21, I wouldn't be saying all this. Now having decades more than that, I don't need to tell you, but having decades.
Why would you not say this if you were 21?
Oh, because I wouldn't have enough experience to have the confidence in my judgment to say it all. It's through you've got, in order to be able to really to stand on an idea, you have to beat on it a lot. In order to say anything significant, you got to beat on a lot of ideas, because you got to. So if I'm going to stand up here and say that there's something good about CO2 and something wrong about saying it's bad, okay, then I've got to check out every little nuance of that argument. I've got to go down to the molecular and atomic level and challenge the theory itself.
You've basically done what I'm not willing to do, which is great.
Well, it's a lot of work, and it's not only that, you're alone in the enterprise. There's nobody going to tell you you're right. You have to decide whether you're right yourself. Now, as an innovator, I've founded 3 or 4 companies that and sold products to many global innovative products to many global 200 companies or whatever. So as an innovator, I know that out of every 1,000 ideas I have, maybe I get away with 10 that are good, and the rest of them I got to just throw out and eat them.
That's what I do. I'll build stuff without doing any market research, which I think is a good idea.
Yeah, no, you learn. You commit too much of your time to something you haven't analyzed the market for enough, and you'll find that it's that you burn yourself. Yeah. So you learn that lesson too. And so basically, So when you go and you say, "Hey, wait a minute, I don't agree with the greenhouse gas theory. How could it be right if all these predictions they keep saying don't come true?" I've seen the predictions of this and that, and the global warming, the end of snow, et cetera, for 20 years. And it's not there. That isn't happening. And then there's more polar bears than ever. And they're using the polar bear to scare everybody. And so you see this over 20 years. And the guy is 21 years old, really hasn't had 20 years to study it. He hadn't seen it enough. So it's very difficult. He can say it. I can explain it to him like I'm explaining to you now. So it's something he can understand that, and then he can go check the ideas that I've expressed. He can think about them in the context of his own experience and knowledge. And so he may agree with me, though. And once I've expressed it, because I've had the benefit of more decades and in technological education and innovative commitment, so he gets the benefit of my taking the chance that everybody's wrong, and then going and assessing the validity of all this stuff. And well, that's what it is. I mean, that's why it's not the primary reason why scientists innovate. We do it because it's cool, That's what I would say. We like it, I like it. We can talk about this later, but I have a reason for wanting to assess the validity of a theory, and I can explain that. So from my perspective, I stick my neck out, but I at every turn, I'm reading a paper from I read a paper from Einstein, and I'm trying to find out what would he say about what I say. And at first it seems that he disagrees, but then I say, no, wait a minute, he's agreeing here. And in this particular instance, he was agreeing that he doesn't really think that the Rayleigh scattering is able to absorb much energy, but he thinks the changes in or the transference of momentum is too, and that therefore he goes along with the rest of the scientific community. Well, I have my spreadsheet, and I calculate the cost of momentum for an infrared photon, right? And then I go, wait a minute, Einstein, you're not right on that. I mean, you're granted, you acknowledge that you might not be right, which is good, but you're not. It is not correct. The momentum transferred and the energy transference to a single molecule from a photon is substantial enough when it is amassed over all these molecules. And not only that, they've made some other assumptions. And I'm digressing a little bit. I'm trying to emphasize this point on the challenging of basic theory, right? Even I've talked to like Professor William Happer as a Princeton emeritus professor in physics, and where Einstein went to or lectured or whatever. But Dr. Happer and I've had dialogues, a dozen emails or whatever, and he hasn't gone along with what I've said, but he made some really silly assumptions, and it explained to me why so much of the community might have it wrong. He says the troposphere, which is the kind of the heavy part of the air, is like 12 kilometers thick. Okay, I'm not going to argue with that. But the fact of the matter is the sun travels. What about how thick is the troposphere at sunset? Well, it's still 12 kilometers thick, but the distance a photon travels through the troposphere is more than 300 kilometers through the troposphere. And so you get your average is like 200 kilometers. So when they're all, when Dr. Happer, and I'm using his name explicitly because I don't feel like he's a smart guy. I'm not going to say he's not, but he's not correct. Some things he's done lately are I go along with, but he doesn't get it. Nonetheless, so a photon travels through an average of 200 kilometers of troposphere of all that's where most of the molecules of the air are. So through all that space, 200 kilometers, that's 20 times more than they're all assuming. Because we're not always at noon every day, If we were at noon all the time, the sun just stood there in the middle, then it would be 12 kilometers that a photon travels through. But it doesn't. Starts from sunrise to the sunset, and it goes through an equal, it passes around as the Earth rotates. So basically that's another invalid assumption. So when they start talking about can there be enough energy transferred through Rayleigh scattering through the photons affecting transferring momentum and speeding up the molecules? And the answer is yes, because because 20 times is an order of magnitude more than they were presuming, because they didn't really check it. And so these are opportunities from a scientific perspective to challenge a paradigm that doesn't seem to be holding water. So you always you start with the hint that the paradigm isn't working because the theory doesn't seem to be confirming the reality. That's when so if the world says the emperor has clothes, and when he doesn't, then hey, wait a minute, somebody's got to face the reality here. So humans are like that. Since we have the capacity to misrepresent reality and then communicate through symbols of our language, we have the capacity to misrepresent reality en masse. I mean, I call it collective insanity. We have a group of dogs really don't collectively become insane because they don't symbolize their communications. They have neural cells very similar to the human neural cell. So they think like we do. They reason. They really do reason. They have the capacity to reason. But they don't symbolize their language, so they can't be collectively really dumb. So these are parts about being human that we have to be really careful of, and it just emphasizes how important it is for each individual in a society to learn how to think for themselves and to assess the validity of the ideas they accept in their mind. And so, it's a like you said, if you go build a product and you haven't done a market analysis, and you end up with a product that doesn't have a market, and that hurts, right? So, not being able to assess the validity of ideas hurts someone.
3 times now.
Yeah, well, you learn, right, and then you grow, and then something that other guys might not be, because there might be other people developing products when they haven't assessed the market for them, So, and you're not the only one, and so we all rise if we can, or if we want to, if we fight to. But if everybody let's just say we go into a pub, if you could do that in London. Can you go to the pubs in London yet? Yeah. Okay. All right. Well, that's good. Well, because that's such a big part of English life, because I've lived there for 4 or 5 years. But anyways, so if you go into a pub and you say, CO2 is not warming the earth, everybody goes, go away.
Well, Greta said that yesterday, that climate change, or a few days ago, that climate change doesn't exist or something like that. Maybe. Oh,
is that right?
Maybe it's a slip of a tongue. Maybe it's a deep fake. I don't know, but it got some traffic.
Oh, we darn. I didn't. Yeah, I haven't heard about that. But the reality is, if we're going to be honest as a society, I think we're going to find that CO2 is one of our best friends as a molecule, and if we had more of it, and this is, I'll credit Happer for saying this. He said, as Happer said, he says, if we had more CO2, that'd be good, because it would improve the productivity of all of our agriculture.
What would be absolutely great, man? If I could get you and Steve Keen on the same show together, and you could duke it out on climate change, man. Jeez, that would be
happy to. I mean, like I say, I'm going in a radical direction, challenging not just the issue of CO2 and how much we should have, and I'm saying the greenhouse gas theory is invalid. So this is a theory that belongs in the dump heap of human history. Okay, it's invalid. Now, I like Fourier. He was a guy with a Fourier transformation, a brilliant mathematician from the early 19th century, 1830s. And he pretty much originated this concept of a greenhouse gas. And Arrhenius, who's from my perspective, is kind of a second-rate scientist, but Arrhenius picked up on it in the latter part of the 19th century and early 20th. And so, but he didn't really. Is his short paper not very not correct? Interesting, and it actually gave a historical origin for a reader. But so, in any case, we have to dialogue these things. And I know, and as we qualify, this conversation is a little bit maybe over the heads of the general public. But I would say, if we spend billions and trillions of dollars on education, this conversation should not be above the heads of the general public if educators were effective and if our monies were being well spent. Everyone, every adult with a basic level of education ought to be able to be on this conversation and contribute and ask legitimate and intelligent questions and be comfortable in the discussion. And so, that's my, anyways, that's what I think.
So let's just circle back to this notion of greenhouse gases and the general public's, you know, passionate with it. What is it that you're saying that's different about the atoms in the atmosphere, CO2 molecules, versus what the mainstream are teaching?
The mainstream is teaching that the infrared radiation that is basically coming back from the Earth is being trapped by the greenhouse molecules. I don't like calling them greenhouse molecules because they're not. Okay, so so what they say is that the CO2 and the CH4 and the other multi-molecule triatomic molecules and above, ones with more than 3 atoms and above, are these greenhouse gases, and that they are trapping most of the energy that's emanating from the Earth, and therefore they're serving like a blanket or a greenhouse. I say, bzz, wrong answer. They are much less than 1% of the air. Well, let's just say 1% because water vapor is a lot. But 99% of the atmosphere is O2 and N2, the diatomics. All right, these two diatomic molecules are storing via another mechanism the much vaster amount of thermal energy from the sun or being re-radiated from the Earth. And they do so by another mechanism, which is via photon absorption of momentum, which results in an increase in their speeds and their velocities. So they're not, so the N2 does not change to a higher energy state.
Yeah.
What it does is it goes faster.
Really scattering.
Yes, from the Rayleigh scattering. That's right. It's going faster. It's absorbing the momentum of photons. And so this is why I differ from the mainstream. Mainstream says IR, infrared radiation from the Earth, is being absorbed by energy state raises by the greenhouse gases. I say, bzz, no, energy is being absorbed predominantly by increases in the velocity of them and the translational velocity of the molecules by photon absorption in the atoms, in the electrons and the neutrons of all these N2 and O2 gases, which are by far the predominant content of our atmosphere. So all the, I'm a heat transfer. I love, I can tell you, well, I'll tell you a story. I was in an honors heat transfer course in Cornell, and the professor was, he was, that was his specialty, is heat transfer professor. He went to, I think, Princeton as well. And he basically, we got in an argument one day for 5 or 10 minutes, and I kept saying this and I kept saying this. He says, no, that's not correct, Kevin. And he kept going on, and I said, yeah, that's right. And he says, no, I'm sorry. And so it was 2 days later, he came back in front of the class. He says, for the first time in my career, I've been corrected by a student. And so I like this stuff, so I have that challenge. But from my perspective, by far, most of the energy that's being stored by the atmosphere is via N2 and O2 from the increase in their velocities, and this is in consonance with right here. Yeah, with the kinetic theory of gases. Okay, so the kinetic theory of gases, and I explain this in my paper. This is one that we kind of learn when we're in high school, at least I did, is that that gases increase their temperature when the velocity of the molecules increase.
Yeah.
Okay. So that's the predominant one. In fact, if we use that presumption or that assumption, then we get good enough calculations for all thermal energy calculations in engineering. That's good enough, is the assumption that the temperature increases predominantly by the increase of the molecules. Okay. It doesn't talk about the vibrational degrees of freedom. That's, especially around room temperature, we even the physicists say just ignore the vibrational modes because they don't really contribute to thermal energy storage.
So you've got three types of energy. You've got these speed of the average speed of the subatomic particles. You've got the energy levels of the electrons going around the nucleus, and then you've got something called vibrational. What exactly is vibrational energy?
Yeah, okay, so take a CO2 molecule. Again, one carbon, two oxygen molecule or atoms. Okay, so if the atoms of oxygen are shaking or coming closer and farther away, that's like a vibration, because they're the only thing holding them together is electrical charges. So they're kind of a spring. Okay,
so that's different from the average speed of the whole.
That's right. Yeah, if you take the whole molecule and you throw it through the air, then that's a translational velocity. And it can go in X, Y, and Z axis. That's 3 degrees of freedom. You got your vibrational modes though. With a CO2 molecule in 3 atoms, you got more vibrational modes because you got more of these atoms that can shake with respect to one another. You see, and whereas in N2 you just have the one the one shaking between the two. So that's their big theory. That's the basis of the greenhouse gas theory, is that these triatomic and above molecules, they have more modes of vibration, therefore they can store more thermal energy. And it's wrong answer. At around room temperature, for instance, we ignore that. And in fact, for most temperatures, and according to kinetic theory of gases, we ignore the vibrational modes. We just look at the velocity. And it's through the change in the transference of momentum from photons by the change in velocity of N2 and O2 that thermal energy has been stored in our atmosphere. That's what warms our atmosphere. But now couple that. Remember what I talked about before? I talked about how when an eclipse is happening, then the earth the ground below it and the air below it cools quickly. It's because the energy just radiates quickly. So, what I'm saying is entirely different. I'm saying there ain't much of a greenhouse, guys. Okay. It isn't really working. Let's just say we had 2 days without sun. Like just say somebody turned the sun off. Okay. Right. Man, after the second day, we're freezing already. We're screwed as a species, and life on Earth. The plants start to wilt. They don't get any sun, they die. Okay, so after a week of no sun, no more plants, no more animals. Animals start to die. People start to die. Everybody starts to die. Boom, we're out of here. Okay, without the sun, we're screwed. Where's the greenhouse? You think the green is going to save us for a month? It's not going to save us for we're lucky the greenhouse saves us for a night, right? Here's what happens. You and any listener go out tonight, at dusk, and then go out before the sun rises and ask yourself, is there a difference in temperature? And you'll say, yeah, it's cooler in the morning. Okay, like duh. Okay, so where's the greenhouse? What happens if the sun doesn't come up? It will keep getting cooler. Okay, so where's the greenhouse? It's good for a night. Luckily, we're here because we have nights. Because the greenhouse was good enough to give us, to not be if we had less air, then by the time, or less of an atmosphere, by the time sunrise rolled around, we'd all be frozen to death. Okay, so it does do something.
I think what the pro greenhouse gas people would say was, obviously the sun's going to come up the next day, so they'll just say like, well, it's the cumulative effect of both the greenhouse effect and the sun shining every day, and this whole cumulative effect is what causes the average rise in temperatures.
Yeah, but you see but the point is the average rise in temperature. I mean, we can have a day that says no one use air conditioning today. Okay, that will drop the Earth's temperature by 0.5 degree tomorrow. Okay, and then when we turn it back on again, we say, oh, it's warmer today, because it doesn't make any difference. If we want to lower the Earth's temperature, then we can all stop driving for the day. And if it's that simple. It's not stupid like they think. They think that we're building up CO2 and that's making more of a greenhouse. And I say, BS. Okay.
So you're saying that the CO2, the carbon in the 2 oxygen molecules, they're saying that this less than 0.001% of the parts of the atmosphere, 400 parts per million, which is less than 1/1000th. They're saying that the infrared that's emitted from basically the ground when it interacts with the CO2 molecules, it's being turned into vibrational heat energy,
right,
through absorption.
Right. But they're missing the forest for the trees. They're seeing. I'm not arguing that the photons in the infrared, there are some wavelengths which are absorbed by increases in excitation and raises in the electron levels. Okay, I do agree. Okay, I'll go along with that. But I'm saying in the broader picture, the 99% of the molecules are increased in their speed by energy coming from the Earth. Okay, forget about the sun. So the Earth's energy is being stored by Rayleigh scattering too. Okay, now there I could go into the nuances also, and there's also other ways that infrared radiation is absorbed by nitrogen and oxygen that is not being acknowledged. And that's through intermediate wavelengths called Raman scattering. And that's another, I don't want to get into it because it gets more technical. But so there's holes all over this greenhouse gas theory. And I've explained, I've got I ask friends, or not friends, but acquaintances and LinkedIn connections to
How about your friend acquaintance?
What's that?
Somebody could say to this is my friend, and you go, you're not my friend, you're my acquaintance.
Yeah. Yes, they're the same. People I know only through LinkedIn that I've never met. I have asked them to evaluate the paper, or they've just made responses to me. So a lot of guys, PhDs in atmospheric physics and physics in general, and engineers, nuclear physics guy, have read the paper and they agree with me. Okay, so I hit it with all I've got, because like I said, I have there's about 6 different ways that I attack the greenhouse gas theory. Okay, so
wait a minute. Once these people read this paper, do they then go publicly share what they think and like how they're against this whole climate change agenda, or they just like don't say anything because they're worried about their
Well,
careers?
what I do, and I've done this without saying anything. I've asked them if I could use the quote, but I don't put their names on it. I just put their qualifications.
Right.
I don't want to get them in trouble. That's not what I want to do. I just wanted to show that, hey, there's a lot of people that agree with me, and these are scientists too. And so, I'll just, if I could read one, hold on a second. Here's one. You have found a promising approach to demonstrate successfully that the long suspected culprits of global warming, i.e. CO2, CH4, are actually not. Okay. So, and this is a guy who has a PhD in physics from Rutgers. Okay. So, and there's, there's others. Here's another, I'll read it because I was just in front of it.
CH4 being methane.
Yes, methane. These are greenhouse gases, what considered to be greenhouse gases, right. CH2 and CH4. They're multi-atom, or triatom and above. CH4 is 5 atoms, so that is even more degrees of freedom than a CO2. But it doesn't make any difference because, like I said, they're not greenhouse gases. The primary greenhouse gases on Earth, right, are N2 and O2. And I will say, right, Mars has about 90.
This is something you could prove in a laboratory. You could basically isolate these atoms and subject them to, limited radiation inside of a zero, as a temperature controlled environment of maybe absolute zero. And
yeah, you have to be careful there too. Okay, this is really important. Let's just say you have some CO2 in a bag and you radiate it, and the temperature goes up. Well, that means if it goes up faster than a bag of nitrogen, that means that the temperature raises faster in one than the other. It means a couple things. It means that it requires less energy to raise the temperature. Okay, that also means that it stores less thermal energy. Okay, so that's a bit of a tricky one, right? So it stores less
Like
thermal
heat
energy.
capacity of the gas, yeah.
Yeah, the heat capacity is lower for CO2 than it is for nitrogen. Okay, that's important, right? So when if you do an experiment in a lab and you show all the kids how the CO2 gets hotter faster, all you're doing is showing them that it takes less thermal energy to raise its temperature.
Yeah.
But that only means that it stores less thermal energy. It's less of a contributor to greenhouse effect, if you wanted to use that term. You follow? Because it stores less thermal energy.
It could also be to do with the rate of transfer. It could be slow in one direction and faster in another direction. Like
true. So, but you have to be careful about experiments, and that's as important about experiments. You have to be careful about what you're measuring and what it is that are you trying to determine whether these particular gases store more thermal energy in the atmosphere, that they're a primary store, and that therefore increasing them will store more thermal energy in the air? Because if you're just talking about,
I guess that the larger the molecular weight, the more heat capacity it has.
In general, that's in general case. But again, you have to go back to the numbers and look, because
then you've got water, for example, which has got a huge heat capacity versus metals. So
that's right. And you have, if N2, if nitrogen is higher than CO2, there's an example of one with only two atoms and versus one with three. And so anyhow, so that's those are real issues. And so but I've seen YouTubes where a teacher was basically trying to convince everybody that because the CO2 heated up hotter than or faster than the other bag, therefore it was a greenhouse gas, and the reasoning is wrong.
Propaganda students, and I just can't
exactly.
understand.
But for a student who doesn't understand the nature of thermal energy, which is really the issue, this is all about thermal energy. That's why I said heat transfer is this is what it's all about.
It's an important topic. Yeah, we should be there should be adverts on television for like heat transfer degrees or something,
Yeah, the amount, basically what we're talking about in a greenhouse is storing thermal energy in the air. If we could store thermal energy in the air, we wanted molecules up there if we wanted to. If we wanted to, or we were concerned about the amount of thermal energy that was being stored in the atmosphere, that would be a legitimate concern. And if we found that more thermal energy was being stored in the air, then we would say that there's more of a greenhouse effect. But with CO2, I say there's less thermal energy being stored in the air, because the higher, now it's only 0.04%, like you said, but it's storing less CO2.
No, it would be 0.04%.
That's right, 0.04%. Yeah. That's correct. That's right. So this is a tiny amount of, but it's actually storing less on a per cubic meter basis than nitrogen. On a per molecule basis, okay, it's storing less thermal energy, and it's doing. So anyways, so like I said, there's other, there's other quotes, and there are other people that agree with me, but there, it's hard going, because it's not. I'm not sucking up.
Well, you've got basically trillions of dollars of investments in green tech that would basically hate what you're saying. So.
That's right. And I will be frank with you. I have definitely had people threaten me. They threaten me with slander. They've threatened me with, lack of refusal to invest. So, yeah, I get it. I mean, I do. And I never want to sell to 100% of the marketplace. I'm always selling to some small part, like 1%. Right? So the question is, okay, so some guy is going to threaten me and he's not going to buy if I don't. Well, tough. I'll find somebody else. So I don't. So yeah, it is. I do have integrity. Why not? And because if I lose 0.5% here, I'll gain 0.5% somewhere else, so figure out something else, right?
I've got quite a lot of green friends. I mean, I don't care if they disagree with me intellectually, but I think that my friends are good enough friends that if I lean more towards your sayings, as long as I'm being objective, I'm happy. if like I'm proven wrong in an objective science, because for me it's all
That's
about the
right.
science. So I'm not here for political things and stuff like that. But if it's,
To be honest, it's more interesting when our views are challenged, and because we're learning, we're growing, and it's the same with me. I mean, I did all this stuff, so like I said, it's taken me more than 10 years to work on all these things and work out all these nuances, and I had to have degrees in it anyways. And that's before the 10 years, and a lifetime as engineer and a computer techie guy. So I basically have a lot of years figuring this stuff out. And so when I come back to the world and say, guys, you're all wrong, first everybody says, what? Who are you to tell us that we're all wrong? How can you say the emperor has no clothes? What, are you crazy? And
honestly, I've been wanting to talk to you. I've been wanting to talk to someone like you for years, and I'm just like, I feel so blessed to have managed to have this conversation, and you've actually have a respectable background, and I continued, respectable background. You're an entrepreneur, and you can speak on this subject so authoritatively, and also in a sense to the detriment of your own financial success, which I completely applaud. And it's we just need more people like you in this world.
Yeah, well, to be, again, it seems, it's apparently, well, thank you, but it's apparently contrary to my interest, but in one respect it's not. In the longer term, it is not contrary to my interests. I share the same world with the rest of the human race, but what becomes of that world also affects me. And so, yes, standing against the crowd, that's kind of, as an innovator, you kind of got that already. I've come to grips with that long ago. As an innovator, I'm ahead of the times a lot. And when I'm ahead of the times, they don't understand me. Therefore, I lose part of the market that doesn't understand it. I lose part of the market that doesn't want me to be right. I lose part of the market that's committed to some other thing and that is threatened. I lose part of the market because they don't want to know about it. And so, but then I gain the part that innovators get. And because I'm a first mover, and as a first mover, I gain the credibility over time. And so like I say, yeah, it seems it's altruistic or sacrificial, but it's not. It's just in a different kind of my interest. So I don't subscribe to self-sacrifice. That's slavery. Anybody who promotes self-sacrifice is promoting slavery from my perspective, and I don't think that's right. We should fight to be successful and happy and free. And we should all fight with all our hearts and souls. So anyhow, but yeah, thank you for that. Like I said, I have my integrity in regard to my ethical values but mostly in science. I too want to learn, and I want to do this right. I don't want to be wrong. And when I go up to William Happer and then I see his errors of reasoning, and then he's like an ostrich, I don't like that. And that guy's on the top of the academic heap. He was an advisor to President Trump. Not that Trump is any great intellectual or anything.
I think that you're a very, very valuable individual for humanity right now, because it seems to me like a lot of the world is wanting to basically bring about world governments on this single issue regarding, the Agenda 2030, the Sustainable Development Goals.
Scary business to me.
It's like we need to be, and the reason that I've not really talked about this subject much before with people that are against it is because I want it to be correct. I want it to be backed with somebody with a backbone intellectually on the subject. And I'm just overjoyed that we've had to manage to have this conversation. Personally, I'm still on the fence, but I mean, I'm glad that we can get your ideas out there. And I think that the real test, the litmus test, will be able to see if we have you on the show with somebody. I mean, maybe pro greenhouse gas people will not want to debate you, but I'm going to try and do that.
Sure.
See what we can come up with. Yeah,
that'd be great. Well, read the paper. It's you can go to climatesciencejournal.com. And there's an invalidity of the greenhouse gas theory is on the papers, so anybody can go there and read it. And I would say that anybody that doesn't know physics if they want to learn physics, it's a good thing to read and study, and take your time. You've got your whole lives, and to have a better grasp of basic physics is always a good. It just makes your life more comprehensible. So it is interesting, and it is a value.
Well, I'll go away and read this paper over a few days, and then I will try and arrange the next interview. Anything you want to share with our audience before we wrap up this part one?
No, that I think we talked all over the place as is necessary when you challenge some basic assumptions. You have to hit it from a lot. But again, evidence should be the driver of theories and the ultimate arbiter, not consensus and not everyone else's opinion. And so anyone who wants to be able to think capably and protect their own interest and that of their families needs to always let evidence rule on any discussion of science, and finding the connection between a theory and your practical reality, like a sunset or an eclipse or something. That's often a key, and something that the mainstream academic scientists often lose sight of. So and where the public might have a better practical approach to that. So
yeah, I appreciate it. Do you mind if I just close in a little prayer?
Yeah, go ahead.
Okay.
Can I qualify it just real quick?
Yeah.
I'm just going to say I was interested in artificial intelligence, and I developed over about a 10-year period a broad-based new epistemological theory, which is a theory of knowledge, including a theory of induction. And I wrote a book, and I show how ethical values are formed by humans through the mental process of induction. And this is new knowledge too. And so I respect everyone's right to their own views on ethical values, but things like that we shouldn't steal. I mean, that's something that was an idea that was invented as soon as someone owned or built something themselves or created something and had it stolen. They came up with the ideas as this is not a place where I want to live, where people are going to constantly steal with me. So I say that's the inductive origin of most of all of our values, or we all have inductive origins of our values. So you're welcome to go ahead and express that. Obviously, this is your online platform. But I do think that we in a future world we'll all comprehend the idea that our values are all human invented, and that we can improve our value systems. So, anyways, go ahead.
Interesting topics for future discussion. If
go.
anyone wants to research more of that, they should read the book "The Abolition of Man" by C.S. Lewis, which explains a lot of the Tao, which is sort of prevalent across different cultures, societies, generations. But anyway, let me just pray, because I feel it's important for my worldview to basically protect what you're doing, and I believe in prayer. But anyway, dear Father in heaven, I thank you for Kevin and his semi-activism / entrepreneurship with just technology, and I pray that this word would get out through him, through this podcast, other podcasts, about the need to challenge the narrative of greenhouse gases, because this world is changing fast politically. And Lord, we ask for your hand and guidance and your protection across people that are challenging this narrative. And we ask that your will would be done on this earth, and you protect this earth and the people that you want to control a lot of the economics that would be favorable towards your goals for the goodness of humanity. We pray this in Jesus' name. Amen.
Okay, so yeah, all right. Well, so thanks very much, Nikos, for having me on board, and I look forward to a future conversation with you guys.
If you have enjoyed today's episode, I would really appreciate if you leave a review on your podcast app of choice. Also, if you would share with your friends, family, and anyone who you think would benefit from listening to this episode. I really appreciate every single one of my listeners. Thanks very much for taking the time to listen to the show today. If you'd like to get in touch, you can catch me on my LinkedIn profile, send a message, or even just email me on my contact page on my website. Thanks very much again. See you again next on the Nikos Show. Bye-bye.